Okay, so Antonio is a permanent faculty staff since 2017 in Salamanca University. Before that, he spent 10 years as a PhD and postdoc in different institutions around the world, like Padua, Leiden, Oxford, Mead, Manchester, or Tokyo. Antonio's scientific interests are in petrology and geochemistry and what they can tell us about broader programs in the earth science. In Salamanca, he launched an interdisciplinary research line on volcanology and petrology that also integrates novel gases and stable isotopes, geochemistry, thermodynamics, mathematics, and geophysics and experiments. So let's begin with the talk From Magma Source to Eruption under Tagoro Volcano, El Hierro, Canary Islands, a petrologic, geochemical, and physiographic overview of the 2011-2012 submarine event. So,
okay, so again, thanks to to Eugenio and team for the invitation. It's a pleasure for me always to be there, this time just remotely. And well, thanks to Nieves also for that spectacular talk. I really enjoyed. Amazing job you did there. Okay, my talk is a little bit different in the sense that, okay, Eugenio told me, hey, this is a symposium for master students. So I prepared it thinking on students, like they were my own students. So all these people in this grade, in the masters, are coming from pretty different disciplines and backgrounds. So I didn't prepare a very, expert petrologic geochemist talk, but just kind of summary of what a group like us work during a submarine volcanic spectacular geological problem. Okay, so hopefully everybody will be able to have fun a little bit, at least those knowing more about rocks and those knowing more knowing about, I don't know, oceanographic stuff. Let's see, you will tell me at the end. Okay, but to be honest, this is almost the real title of the talk. Okay, so let's learn to read the sentences written in the rocks. This is what I tell to all my students. The rocks contain, rocks is the key material connecting what is going on at depth and what is going on at surface, which is the only material the scientists have access. So we have to figure out and learn to read what is all the info registered at depth to understand what was going on and what could be occur in the next upcoming eruption. Okay, so this is the key material to go further. Okay, so this is the material we got. We started to. I'm closing this. Okay. So these are all the Tagoro material coming into our vessel. We will see now a picture of it. The first thing is select the places to collect the samples. This is the only access we have to the deep magma chamber at depth. Okay, this sounds pretty obvious, I know, but maybe not for all the master students. Okay, this is the way we take the samples, also water and all other stuff in the ocean. This is our friend Eugenio taking a present for Antonio down there in the seafloor. Our super Angela Salvarino vessel and the material to get studied. Of course, at the same time, all the super geophysicists are taking all the maps and all the info of the seafloor to be compared and integrated in the petrological material. And okay, this is the very beginning of our lesson about how to learn to read the rocks. And these are beautiful images of what the rock looks like. And you can see how petrology start reading though that info reading at depth. We have several nice phenocrysts, olivines, clinopyroxene, blah blah, plagioclase. If they have inclusions, yeah, if they are fluid or mel inclusions, amount are textural, morphology of the bubbles of the vesicles, if there are or not microliths, blah blah blah. Even if we have some kind of alteration in the rocks, and all this is the very base of our reading of the rocks at the beginning. Then we will do all the chemical and geophysical stuff, but this is the beginning to start understanding our material coming from depth. Okay, after that, with the knowledge of the rocks, we start to do crazy things to the rocks, and we start obtaining the bulk rock composition of our magma at depth, and also how that magma evolves during its ascent to the surface. So if there are variation in the composition, blah blah, because all of that will help us to understand how the eruptive event triggered and evolved since the beginning to the end. In this case, we applied a special procedure, we can say, and is comparing the composition at depth with the location at surface, and the moment of the eruption during those months from October to February, March, from 2011 to 2012. Okay, so classical geochemistry. Also more on geochemistry, studying stable isotopes, oxygen and deuterium, to be able to trace sources of the different magma source, doing different calculations of, for example, magma residence at depth with the beautiful olivines found at depth. So isotope geochemistry, diffusion chronometry, and all the thermodynamics behind, after having all the compositions, to estimate and calculate pressure and temperature conditions of these magmas. Okay, hope you are enjoying a lot, like me, with this stuff. Okay, yeah, in one of our crises, we have on board a real expert on magnetometry and the special instrument for it. So we also integrated in all the information, this data, to see if there was any magnetometry anomaly at the moment when we were sampling the samples there. So we are more or less able to get also these spectacular images from my friends and colleagues of the Oceanographic Institute, which are the only person able to get some kind of spectacular image of the seafloor behind the Cruz. Okay, and this is, okay, the real moment when the tears come off from the ice, when we are able to integrate all the puzzle pieces after lots and lots of reading of the information reading in the rocks and in the other disciplines, geophysics, etc. So we were able more or less to integrate and, well, at least advance humbling in the evolution of the Tagoro eruption, going from depth when the magma start triggered up to the last morphological edifice situation and location and current emissions that there are. Eugenio told me that acidity, temperature, and everything is evidencing that everything is life still there. So the geologists, petrology, geochemistry, blah, blah, are able to build a 3D model, more or less, of the whole picture going on under Tagoro. So we were able to identify 2 different magma chambers, more or less the time of residence, when they were triggered by the arrival of a deeper pulse, and then even to correlate the samples found at surface, at what moment they came during the eruption, if near to November 2011 or near to the end of the eruptive pulse. Okay, the next slide more or less summarize with what I've just said. So kind of origin, about 2 magma chambers at the end, one deeper at 24 kilometers, ascended and differentiated and mixed with different pools staked at 12 kilometers more or less. The eruption partly emptied the plumbing system during the whole eruption period. We were able to understand how also the stingolitic material were able to produce, of course, in base of previous works of the groups working in the Canary Islands. We were able to also constrain that the magmatic evolution and resident time from the previous 2011 eruption were also pretty similar, and they were not that affected by fluid rocks interaction. So we concluded that they were not due to an arrival of external fluids triggering an overpressuring the magma chamber depth. Okay, we saw that there was also a present day anomaly in terms of magnetometry under Tagoro, and we also estimated a minimum volume comparing the bathymetry of the pre and the post eruption with the help of the IEO colleagues of this volume. And of course, again, this is a minimum amount. Okay, and all these have been, as I mentioned previously, summarized in a special paper of a special volume of Springer book devoted to Tagoro, and hopefully it will publish someday in the next millennia, because it's taking really long. But okay, you know, managing with many papers and books is normally pretty tough. So hopefully will be published soon. Okay, yeah, this is kind of summary, which this is to convince to all master students in Tenerife to come to Salamanca that what we are doing in our group in collaboration with Tenerife and many other groups, and this is more or less what we do to constrain a little bit more all these submarine or on-land eruptions. So we combine lots of petrological stuff with really modern techniques, microcity, FTIR, Raman, doing noble gases, studying the morphology of the bubbles, blah, 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 integrating experiments, and then combining with models, mathematics and thermodynamics, okay, to try to see if numbers really match what the real life say. Real life, you know, is rocks. Okay, and then yes, always calling our colleagues to integrate and a whole picture of the problem to be studied. Okay, and yes, we are doing this in Tagoro, and our current project is working in another special places like Deception Island, Ruapeu, in northeast of active volcanoes in Japan, Etna and Vulture, in Iceland, also some special mar basalt from lunar rocks. And okay, this is just again to convince your students to move to Salamanca. Hopefully. Okay, and the last slide is just to show a special chapter in the reading books of Tagoro rocks. And this was yes, it was born like a crazy hypothesis, but it was a happy end, also full of tears again. And it was combining yes, it was like a crazy idea because nobody tried to do it in those days, and was comparing in a more closest system, we can say, if we compare a submarine scenario with an on-land volcano, how the gassing from the magma chamber could be registered by organisms, and if is in a submarine context, is much easier to control that in an open atmospheric scenario. So we knew that under Tagoro we got the seismic activity by physics, and by gases emission we get the geochemical signal also, but this is in Tagoro and any other volcano in the world, of course. So we know that both signals are from an eruption that is already ongoing and is already not evitable. So it's essential and crucial for us, for the scientific community, to get this signal as soon as possible to have a better reaction to it. We can remember the tragic episode in Ontake, where our Japanese colleagues are the real expert in getting these signals in advance. But you know, magma chamber came a little bit more acid, and all the warning perimeters were not enough to avoid this final sad end. Okay, so sorry, in this case was, hey, okay, what's the question in here? When the magma starts to get unstable and starts to release gases, it is at the same time of the eruptive activity in terms of seismics, or not? Is coeval or is even later? So we try to analyze one of the key signals from the mantle, which is the helium isotopic ratios. And the way to analyze that is in those beautiful crystals that grow up in the magma chamber called olivines, that when are in that moment which they are growing up, they are trapping also melt and fluid inclusions, which are like a snapshot of what is going on in the magma chamber and in that real moment of the magma triggering. Okay, so we separated the olivines in a sample that was previous to the 2000 eruption. So it was like a witness of the big event. Was really funny at the beginning, especially for a fully inexpert guy like me in this topic, and was seeing these organisms, black corals, happily growing up and laughing when we collect them at depth. So they were there watching the eruption at depth. Amazing, isn't it? Okay, so they were witness of the eruption, so they legally were hopefully, or we thought that they were able to register this magmatic signal. So, okay, we thought the beginning of the lava eruption was in October 2011. The seismic activity was registered a few months earlier in June. We studied the corals in this data, and we knew through our expert colleagues in this kind of organism that they have this growth rate of around 2 centimeters per year. So we estimated the age of the corals, and they were around 29 months old. Okay, so I took this guy here and cut it the amount of coral material that was properly as witness of the eruption, and then I took off the rest of the body and analyzed both for noble gases. And we were really happy because we got this signal, helium-3,4 helium in the black coral was let's say absorbed, if you like, around 1 month earlier than the seismic activity started in June. Okay, so this well, this is our humble contribution to in eruption in volcanic eruption forecasting. You know, this indicate that maybe the geochemical signal can arrive even earlier than the geophysical one, which is really difficult to measure. But you know, even in Ontake, after all the episode, there were much higher signaling in this helium isotopic ratio than normal. And this is also applied in Etna, and we have just applied also in Deception Island. Okay, this is the end of my talk. Special thanks to everybody, you know, and also for the master students that like and love to learn read rocks. Thanks to the project that were able to fund us, also the crazy ideas, and yes, all the guys there. So hope my voice has been understandable enough and the content also easy enough to follow. Thanks.
Thank you, Antonio. I mean, it was great. We could understand very well. So now we have
Okay.
some time for questions here in the auditorium.
You were able to say that there was not much external water influence pre-eruption in the conduit. Can you go a bit more into how you were able to determine that?
Yes, but we were able to constrain that by taking off the deuterium protium ratio, in which if you have any contribution of external water into the magma chamber, it right away change the isotopic ratio. And in the olivines and even in the glass of the lavas, in those really fresh pieces, of course, there was not that interaction. Yes, it was also pretty surprising. But you know, the deuterium protium isotopic ratio is really reliable on that. Was that your question?
Yes.
Yeah, thank you.
So maybe another one from here, from the auditorium. Or we can go to the questions on the chat.
How were you able to analyze it, like to know which was the composition exactly, like the cases that were registered by the corals?
But the yes, well, you know, any organism, especially corals, don't need any other stuff coming from the seafloor to grow up. So we just analyze the organic material of the coral, putting in the ultra high vacuum mass spectrometer, and that's it. All the rest of the stuff was purified in the line to avoid any contribution of any other crappy thing that was not interested for the hypothesis. Yes, but our big surprise was to know that this special species of coral was not calcium carbonate skeleton, you know, because an inexpert like me was expecting, okay, if I find any volatile or any fluid in the skeleton of these guys, will be in fluid inclusions, for example. But after doing several analyses in the in the lab, we got that it was fully kind of proteins, only organic materials, and we discovered with through micro CT images that there were also like special inclusions that should be able to host that inclusions, and also until nobody demonstrates the opposite, maybe those helium is able to be dissolved in the organic material, maybe. Yeah.
Thank you very much.
Okay.
Okay, if the type of rock depends on the type of rock that you measure, depends on the type of eruption that you have.
Well, yes, we can say somehow you can find special features of the type of erosion also in the rocks. Yes, this is also a particular information written in the rocks. Yes, when you combine textures and chemistry and geophysics in the whole picture, yes, this is one of the parts. Yes, yes, because you can have a faster ascending event or episode, and this is recorded by the rocks also. Yes.
Okay, and we have another question from Ben Ireland. Well, first he said, really interested talk, Antonio, and thank you. Has the novel coral technique been applied to other regions? And if so, do you see the change in alien register before other methods?
Well, if any other try to analyze this kind of samples in a ultra high vacuum mass spec, is better that start praying, because when you analyze, when you burn or crush any of this material, which is pretty rich in CO2, you are damaging the instrument. This is the real problem to get this. So I can confess that after doing this, I need to have the instrument for 3-4 months in the intensive care in the hospital, because the entire line was contaminated because of this. But yes, my advice is, well, we try it. We can confess that we try to apply this technique, for example, in diatoms, because you have fully silica skeletons, and this is not damaging at all any mass spec. So if you want to find a witness of this kind of processes at depth, it's much better to get, for example, diatoms. The problem with diatoms is, well, we tried. There's almost no group in the world able to separate a few milligrams of pure silica mass of a skeleton to analyze, because we tried, and we are doing kind of mass balance, because there are always some of pyroclastic material, glass. Is really almost impossible to separate. But yes, you can try to do it. My proposal is trying to convince the engineers to design tough mass spec to install in the seafloor to measure this isotope. I know there's a company in Japan trying to do it. And yeah, my colleague Sumino-san is using it in Japan, but it's like a pilot procedure so far. Okay.
Okay, I think we have time just for one short question also from Ben. He asks, are there any seafloor gas sampling techniques that can be used to measure the signal that has been measured in the coral, for example, in areas where the coral may not be growing?
Yes, well, yeah, it's more or less the same answer in that sense. No, if you don't have corals as witness, you need other organisms. If you try to do it in a submarine scenario, which is much better than doing it online. But yes, you need to try to for example, in Deception we tried with bivalves growing in one of the submarine cones in the Foster Bay. But again, this is a nightmare for the instrument because as soon as you crush or burn this kind of material, you get tons of crappy CO2 for the instrument. Yes.
Antonio, Eugenio speaking. Thank you so much, Antonio, for being here also. You look great, even with the flu, you look great. So thank you for that. I hope to see you here soon in our cruises. And yeah, thank you so much, Antonio.
Okay. Thank you to you always. Cheers.